Listen, I'm sure we're all having a great time, right? We're having a great time. And without further ado, we'll move into the next session, which is going to be very engaging, I believe, right? It's the presentation by those who have participated in the hackathon. So we have 5 teams. Yeah, I heard who. Yeah, you can make noise for them. Yeah, you can. I mean, these guys have gone through a thorough datathon, right? And now they've emerged as top 5, and they'll be sharing with us, right, right here. Now, let me just give you a brief about the datathon, which is designed to provide an avenue for students, for enthusiasts, for new entrants, as well as professionals in the data space of analytics, data engineering, data science, machine learning, or local development to challenge themselves to take up projects and tasks aimed at using data to solve real-world scenario-based problems, build and grow their portfolio, and create an avenue for networking and working with fellow data professionals. Now, we have the teams and we have our judges. So I'm going to present the names of the judges, and then Ife will tell us about the teams in a moment. Now, some of the judges are here on premise. Some are connected live, so they'll be listening to the presentations from the hackathon team, right? So please, you want to make sure that within 4 minutes, you can pitch your idea, present your idea, and then the judges will take note. Right. Now, speaking about our judges, we have Andre Bryce, who is the founder of Willowfinch, right? Please, you can do that better. You can give a round of applause. They'll be judging. We have Seun Ogunsoya, who is the team lead, Data and Business Intelligence at Providence Bank PLC. No, you can do that better. A round of applause. You know, you are celebrating yourself by doing that. Then we have Ayodeji Adedayo Fanion, who is a senior data scientist at PwC UK. Yeah, you can do that better. Then we have Jennifer Ebe, who is a data engineer at Starling Bank. We have Gilbert Langard, who is a senior data scientist at Ezra, also one of our judges. And last but not the least, we have Fatai Sonny, who is a data analyst, Reliance Infosystem, also right here as a judge. Now let's meet our hackathon participants.
So we have 5 teams that are here to present their solutions, and they'll be coming out one after the other to present their solutions. We have Team HIT, we have the Dream Team, we have Team Vanguard, we have Data Hub, and we have Data Dynasty. We're going to start with Team HIT. Team HIT, please let's give them a
round of applause. They will be presenting in 4 minutes. So we believe you'll do a quick one.
Hello everyone, we are Team HIT and we'll be presenting our projects for the Datathon. Starting with our data engineering project, the objectives of this project was to design an ETL pipeline that extracts, transforms, and loads data into fact and dimension tables. For some reason, the slides haven't come up yet, so I can't really show you our ERD diagram. But essentially, all the data comes from a primary source, which is the sensor data. So we have them connected through timestamp and sensor ID where applicable. All right. So moving on to our data analysis. So please, next. All right. How much do we produce? AG Resources has produced for 2022 to 2023. We have about 1.91 million kilograms per meter squared of crop monthly on average. And the crop we produce the most of is rice, and the least is wheat. Next slide, please. Okay, revenue and crops. So to find how much each crop produces revenue-wise, not profits, because we actually aren't giving the production costs, nor are we giving the exact crop variety. So this is an estimate. We use the minimum retail price of these crops in the US. Barley is crop producing the most revenue, while corn is producing the least. Next slide, please. When to plant. All right. So here we have, on this slide, you can actually see the month which each crop produces the most yield and the ideal time to plant based off this high yield month and also environmental conditions. For example, rice, we have our most yield in October, and rice is best planted between March to October. If you were to target October, you'll be looking at August. Next slide, please. Okay, so we are looking at the effect of various environmental features on our crop yield. From these charts, we can see that at a pH level of 6, we have more crop yield compared to others. At light intensity of about 6,000 lux, we have more crop yield. At a nitrogen level of 6.83 also. Next slide, please. Okay, what region is most profitable? We can see that the east produces the most yield, but it also has the most locations. So when we look at the average yield produced per location, we find out the west actually produces the most yield for each of the farms. So it is the most efficient. And the east produces the least per farm. So we can say it's the least. Next slide, please. Okay, elevation and regions. On this chart, we've separated our locations into high elevation, low elevation, and medium elevation areas. We can see that the east and north have the most high elevation areas. The west and central have the most low elevation areas. Please, next. Okay, save that water. So this actually shows us the best irrigation method to use depending on elevation and water source. As we can see, for high elevation areas, using the drip method tends to be faster regardless of water source. But when dealing with low elevation areas, aside with lakes, the flood method happens to be the fastest. Next slide, please. Okay, the map is in loading, so next slide to not waste time. That chart, the previous chart was supposed to show you the different locations where AG Resources plants. AG Resources plants all over the world. But then we noticed some locations are actually on the ocean, probably an issue due to data recording. We also see that some of the locations are planting multiple crops, but some combinations are not ideal. For example, we have rice and wheat being planted on the same location. But rice requires a lot of water, while wheat would not necessarily survive. Please, next slide. Okay, weather and plants. For example, we can see tomato which would not survive at temperatures below 10 degrees Celsius, being in the seedling stage while it is snowing. Next slide. Pests on the farm. This chart shows us which pest is most severe during what month. So we can see that fungi is more severe in March, May. Next slide. Okay, this just shows us each crop and the pest that affects them the most. We can also see when the pest strikes. The pest actually happen to strike during the seedling. Okay, next slide, next slide. Let's quickly go. Next slide. Next slide. This is just a crop cultivation schedule showing the best time to plant. Next slide. So we have a 3-year crop rotation plan that actually separates our specific crops by seasonal, the seasons where they grow. So from this allows the soil maintain its fertility and reduces pest growth in these regions. Please, next slide. The integrated pest management plan. This just shows us how we can manage pests. Next slide. Okay, next.
Okay, so this is our expansion plan. So for expansion, we've selected the western region and the eastern region. Now in the western region, we find out that the climate is particularly favorable to a large number of the crops cultivated by the organization. And we also discovered that, as we've previously said, the efficiency in the land use is particularly higher. So per every extra meter square of farmland added would produce about 1,700 kilograms of crops. So we have selected the preferred crops that should be planted in the western region. And in the western region, the preferred crops are wheat, rice, and corn. These ones should be planted solely on the new farms so that we can also boost production. Next slide, please. So here we have the crop timing cycle. Time is everything, especially time is money, and especially when you are in agriculture. Next slide. So, sorry, next one. Yeah. So the eastern region yes, the eastern region is the most productive currently, but apparently it doesn't have as high level of efficiency with land use as the west. So we are going to be focused on improving what we have already. So what we've decided to do is that 40% of the existing farm locations will be retrofitted in order to produce only the top 3 producing crops, which are rice, carrots, and corn. Next slide. Sorry.
Thank you.
Sorry, just the last one.
All right, please give them a round of applause. Thank you so much. You see, when you are passionate about your work, you just want to go on and on and on. But unfortunately, we don't have all the time in the world. So thank you so much. Now, the next team.
The next team is the Dream Team.
So the Dream Team, please make your way to the stage. 4 minutes, please. Now, we're going to be very strict. So talk about the most important points, convince the audience, and convince the judges, right? So please give them a round of applause as, okay, only one presenter? Okay, all right, as she comes on stage. So 4 minutes, and the time starts now. By 47, you should be done. Thank you.
All right. Okay. Wow. Please, can you put up my slides? Yeah, thank you. So what I want everyone to do today is picture yourself as a farmer or as an agricultural executive. You plant crops and you collect data on these crops you plant. You also collect data on the method of water you apply to these plants, their irrigation. And then you place sensors all over agricultural locations. What these sensors do is they collect millions of data about light intensity and moisture content. And of course, this data is stored where? In your Snowflake server. So with all of this story now, how do you bring forward a data-driven expansion plan from this? You have all this data. How do you make sense of this? So this is where my team comes in with our solution, AJ Resources Expansion Plan. Please, can you move forward to the next slide? Of course, we started with the data engineering. Our data is stored in a data warehouse, which is what we call our landing zone. And from there, we moved to creating a staging systems. So in this process, we defined our data structure. Finally, we took it on to the modeling stage, where we created facts and dimensions tables, and other business aggregates as well. Then finally, we're able to take it on to Power BI for reporting. Can we move to the next? Okay. So first thing, one thing I want you to know is that this data is covering the year of September 12, 2022 to September 12, 2023. So this is the span of the analysis. So to start with, what we're trying to do is provide an expansion plan for this. So I started off with crop profitability. I wanted to understand which crops are generating yields. So I had to go through the route of finding the total yields. And we found out that approximately 13 million kilograms per meter square is gotten from our crops. But how does this make sense to us exactly? What can we tell with 13? So I went on to do an average. And you can find out from the slide that on average, for every meter square of land you cultivate, you would get 6.83 kilograms of crops, which is, let's say, 7 kilograms, which is quite good, actually. But what if we're trying to check minimum and maximum? What if we want to know our minimum and maximum yield? So if you try to check this now, you see if we're doing really bad, if you check the chart over there, you see we have about 1 kilogram for every square meter of land, and that's quite bad. Then if you check maximum, you see 12 kilograms rather, which is actually quite good. So we know about our yields now. Let's see how the yields are distributed amongst the crop types. Checking that by the average, we see only just slight differences, but we see sugarcane and corn leading the chart. So with this, I've seen the trends of how our crops are being distributed. But what I want to see now is about the trends over the years. Are there certain years or certain months when we seem to be getting the most yields from our crops? We're looking to expand. We need to know how we can expand with an increase in profits. Making revenue is our very sole aim. So starting with, can we go back to the next slide, please? Go back to the previous slide. Go back to the previous. Yes, thank you. Starting with, you check your trend line. Checking the trend line, we can see months, November, and other months highlighted in red, where we had a dip in the average crop yields. So I wanted to understand, why did we see a dip in this period? So I decided to check factors. And you can see factors such as our wind speed. So what I did was I picked a range. Checking online, you get 6.705 as the maximum wind speed for this. So going to this, we now discover that during this period, there are the wind speed, when the wind speed was above this range, it coincides with that same period where we had minimum yields. Then I also checked, and we can also see some pest occurrence in March 2023. Then finally, I provided a general overview of the crop types there. Can we move to the next slide? Then I decided to go into the irrigation and water resources to check on average how many minutes we spend in our water source, which is about 30. And then I provided some insights on the irrigation duration in years and the water sources we have across this period. But what I want to take you to is the interesting part of this. Can we go to the next slide, please? The next slide. Thank you. Can you make that bold? Okay. So the next slide is about regional profitability. We have about 753 agricultural locations, which is split between 5 regions, the north, west, south, and east. Having these agricultural locations, there are some of the factors that affect this. We want to pick a location. And to pick a location, one thing I want you to know that is your crops are important, and some certain factors you need to know. So you need to consider light intensity in picking a location. If you're going to plant certain crops that require ample sunlight, you need to consider
Time's
that.
up.
So what I did was I created a chart showing you the light intensity, and when it's greater,
Please give her a round of
you can
applause.
see this.
Thank you
Going
so
on,
much.
what I would recommend is diversification and crop rotation for this plant.
Thank you.
Thank you very much.
Thank
Now
you.
this is what I have for
Thank
you.
you so much. Thank you so much. Thank you very much.
Thank you, Dream Team. We have our next team, Team Vanguard. Team Vanguard, can we have you on stage, please?
Team Vanguard, let's have you. All right, please give them a round of applause as they come on. Thank you so much. So 5 minutes, watch out for your time on the timer. Once it's time up, you have to stop. All right?
Okay. Good afternoon, everybody. I'm Joseph, and here with me is Joke and Ibrahim. Together, we are Team Vanguard, and we're opportune to work with the Ag Resource project. So before we continue, because of the projector, you can check the slides on your phone at bit.ly/team-vanguard, VANGUARD, and you can scan the code there to follow up. Thank you. So next slide, please. So working with Ag Resource, 2 major problems were our concern: expansion and strategic recommendations. So what we ended up working with is improved pipeline, predictive models, and data-driven recommendations. Next slide, please. In our data engineering pipeline, we worked on a simple ETL process where we used a Python script to pull data away from snowflakes using the Snowflakes Python library, clean data, get our facts and dimension tables, and push those tables back to snowflakes. Next slide, please. Looking at the overview of our data analysis project, Ag Resource had 5 regions, 10 crops, 5 different growth stages, 40 million units total over the last 1 year, and 2.5 million units in the harvest stage. I'll be handing over to Joke to take over from me.
Thank you, Joseph. So looking at our crop analysis, we discovered that rice has the highest yield, and we can say with that rice is the most profitable crop. Also, looking across region, we can see that the East and the North are the two regions with most yield, and we can say they are the top two most performing region. And also, looking at our line chart above, please go to the next slide. Yes, yes. Looking at our irrigation and at that line chart above, we can see that there is a correlation between our soil moisture and our crop yield, because you can see that as soon as irrigation dropped, soil moisture dropped as well, and that caused crop yield to reduce. So overall, we can say that to maintain higher yield, we need to ensure that our water levels are optimized. Next slide, please. Okay, so our water optimization analysis. So after analyzing our water sources and irrigation method, we discovered that our drip method is best suited for our well, our flood is best suited for our lake, and also our sprinkler is best suited for our river. As we see that the combination of these two methods provide the highest yield. And also across the region, no, previous slide. Thank you. Across the region also, we can see that yes, we can see that well produced most of the yield in the central, east, north, and west region, excluding the south region, which lake produced most of the yield. Next slide, please. Thank you. So diving deep into our regional profitability analysis, we're able to see that our top two most performing regions are the east and the north region. As we can see that these two regions provide the highest yield, and therefore they are our most profitable region. And looking across the irrigation analysis also, this same east and north also provided the highest irrigation. So we can see that there's a direct relationship between our yield and our irrigation. So in order for us to have higher yield, we need to ensure that our irrigation is properly monitored. Next slide, please. Thank you. So diving into our risk analysis, we also discovered that our greatest threats to yield are pests and water. So looking there, we can see the two highlighted parts. Which one is sugarcane? We can see that sugarcane has low immune to pest attack, and rice has high immune to pest attack. So now to ensure that we don't reduce our yield, we need to ensure that our soil moisture is properly monitored, as well as our pests. And we can also see with this chart that there is a similar trend between our precipitation, that's our rainfall, and our rainfall, and also our soil moisture. So the higher the irrigation, the higher the soil moisture. So I'm going to hand over to.
All right, thank you very much, Joke. So looking after taking care of the risk, we decided to build a model around risk analysis. So we realized that soil moisture, battery life, pH of the soil are things that indicate both severities and the intensity and the types of the pests that affect our yield in general. So we created a model that the company can use to predict how severe and what kind of pests can come in place. So next slide, please. So our recommendations is increase investment in rice, expand investment in the east and north region. South should improve their irrigation so that they can produce more yield, improve the sensor battery life, and manage soil moisture properly.
Amazing.
Thank you very much.
Amazing. Thank you very much.
Thank you, Team
Thank you,
Vanguard.
guys. Yeah.
We have our next team, Data Hub IQ. Let's give it up for them.
Please, let's give it up for the next team as, the representative is coming up. 5 minutes. All right, take us on.
Hello, everyone. My name is Jethro Olowole. I rep Data Hub IQ, and I want to shout out to my teammates, Azan and Shidera. Unfortunately, they are not here. So this is a farm data analysis for agri-sources incorporation. We receive the data set that include data from pets, crops, location, irrigation, sensor, and all of that. So next slide. The next thing we do was I have to move that data into, I love working with SQL for data transformation, ETL. So I move it to PostgreSQL and do all my data analysis transformation there, then generate 3 important tables. And if you look at the architecture, we have 3 tables we created for fact table, the one we call farm fact matrix. This table combines all the data that has timestamp using the date. So we have 6 tables in that table. We have the location crop matrix that join the location with crop data and other environmental data. So we have the location pest matrix. Because of the volume of the data set, we should have had the location farm matrix, but to be too large, we have about 2 million rows for each set, so the volume will be too high, so we just break it to that too. So because of want of time, we stop with that free. Now, next slide. I'm going to mirror this presentation around the deliverables for the data analyst for the data hackathon. So I'm going to run through it because of time. Next slide, please. Okay, in this presentation, we are asked to find the profitability of the crops. You know, I could plot the crop yield against the crop type and get the figure, but we are asked to, you know, consider the environmental factor. So one approach is to look at the present prices and then consider pest costs, but those data were not supplied. So I go for other options that use profitability index. So what I did was to assign weight to each of those environmental factors that affect the crop. So, and I researched how much weight should be assigned based on how they affect the crop. Then multiply them by the crop yield, the figures, then add it to the crop yield. So when I plot the crop type against the crop yield, the result is a bit different from just plotting the crop type against the crop yield without considering those profitability stuff. So you can see from the results, our profitability results. Next slide. So the next slide, consider water resource allocation. Please go to the next slide. You can read, those tests are recommendations based on the results. So if you have the file, you can read it later. Now look at this picture. Think of it as a waterfall. When we plot the crop, we use the location farm matrix, farm fact matrix. When we plot the crop type against the water source and the irrigation method, you find out that the one that yields the highest results is the flood method, the sprinkler method rather, and the water, pond water source. So I think this side, if you can move the slide this way, the highest point there, the highest point on the left, you have the irrigation duration. At the bottom, you have the water source and irrigation method. So the highest point there represents the point where we have the sprinkler method and the pond water source, which is now the best combination for our farm. So this slide you are seeing, we are now taking the average value. Okay, when you look at the total value, you might say that that combination is the best, but it's not in all cases. When you take the average value, you now see that flood method and pond water source is the best combination where there is little water resources. And that is what you get from this average. So we now come to the conclusion that if you are dealing with where there is enough water, you take pond, irrigate the farm with pond, then you use a sprinkler where there is enough water and flood where there is less water. Next slide, next slide. So this is regional crop yield. You can see the East region using the best results, and of course, followed by the rest. Thank you.
Thank you so much. Please give him a round of applause. Thank you very much. All right, without further ado, we'll go to the last but not the least hackathon team.
Yeah, so the last team is Data Dynasty. Please let's have it up for them.
All right, Data Dynasty, let's have you.
Hello, everyone. Okay, I'm starting my presentation with a story. Okay. In a quiet village from Sound City, there lived an elderly farmer named Jacob. Jacob's crops suffered from harsh weather conditions, and that led to low harvest. But because he was a wise man, he decided to put in the work, and that led to a bountiful harvest. Then one day, Sarah, a younger farmer, she went to Jacob for advice, and Jacob told her, Sarah, farming and life are the same. You sow your seed and you reap your harvest. And you need to know where to sow and when to reap. And he also took her to his field and showed her his own field. And he told her, Sarah, different fields require different irrigation method. You must pay attention to the soil, the sun, and the water. And you must use technology to your own advantage. Sarah took Jacob's advice, and she got her own bountiful harvest. Just like Jacob's story. In farming and in life, the power of reaping and sowing depends on the choices we make. And that is why my team and I are here today to present to you the actionable insights we generated for AG Resources to optimize their crop yield. Thank you. So please help me change the slide, please. Okay, so our ETL pipeline just shows how we took the data from Snowflake to Power BI and then for reporting. The next slide. Okay, I need to move close, I use glasses. Okay, as you can see, our data set is from September 2022 to September 2023. And looking at it, we found out that they had a total yield of 14.33 million for the both years and a total harvest of 2.57 million. And can you please just show me year 2022 and year 2023, just briefly? Okay, so for year 2022, you can see that they got a total yield of 4.33 million and a total harvest of 774,000. And in year 2023, please can you just show me year 2023? Thank you. They had a total yield of 9.9 million and a total harvest of 1.80. So please can you show me both years together? Okay. No, the both here back, sorry, so I can be fast. So together you can see that the best crops that gave the total yield were rice, carrot, and wheat. And you can now go to the water resource, so we can just be fast. And then looking at the water resource, we can find out that this is the time they spent on irrigation. And you can see that for both years together, quarter 1, quarter 2, quarter 3 was quite low than quarter 4. And that result can be found in the total yield per month. And apart from the fact that they took time on irrigation method, they also took time on their growth stage, which was fruiting, and they had a great harvest. Let's go to the region, please. The region. I tried to just go with the time. And looking at the region, you can find out that when it comes to temperature, the southern region is more preferable than the eastern region. But the eastern region had a higher humidity than the southern region. So let's go to the insights. Okay, the recommendation we have, though is not clear, is that we want AG Resources to focus more on rice and carrots since they had a better yield with that. And we also told them that they need to focus more on crops that have less humidity for the south and crops that can, maybe retain more water in the east. And then we also told them that for profitability and for more yield, they should focus on the same product that they had earlier, which is carrot, rice, and wheat. Thank you. Had to rush. So thank you.
Wow, thank you so much.
Thank you, team. Data Dynasty.
Okay. So in second runner-up, that's third position. So we had 5 teams participate in the data team, and we are going to be calling the top 3 teams that performed exceptionally well. All teams performed well, by the way, and the competition was very, very stiff. And then we have all our judges submit their scores, and we aggregated everything together to get the final score for each of the teams. So in second runner-up position, we have The Dream. Do we have The Dream? The Dream, please. A round of applause for The Dream, please. A round of applause for The Dream. Okay, thank you so much, The Dream. So in first runner-up position, that's the second, we have the Data Dynasty. The Data Dynasty, please. The Data Dynasty. Do we have the Data Dynasty? Okay. A round of applause for them, please. Okay, thank you. Thank you. Okay, so before we announce this year's winners, I also want to take this opportunity to appreciate the people that we worked together on this year's data team. It wasn't me alone, we had a team. So I'm just going to mention some of their names. We have Ife. Ife worked with us on the data team. She was very helpful on the data science side. We have Ebuka. Can you please step forward so that we can? A round of applause for them, please. So in absentia, we have Ebenezer, who also worked with us. We have Chuka. We have Paul. We have Seriki, who also worked with us. So a special round of applause for the data team, please. Okay, now, so are we ready to welcome the winners? I can't see the excitement, guys. I can't see the excitement, please. Okay. It's not easy. It's not easy. It's been a long journey. It's been over a month's journey, right? So we have to really appreciate the work that these people have put into the data team. So the winners for data team, Data First Africa 2023 data team is Vanguard. Vanguard, please.
For the champions, stand up.
A round of applause for Vanguard, please.
Stand up.
Can we stand up? Can we stand up, please? Can we stand up? Can we stand up?
Champions, stand up. For the champions, stand up. Stand up. Stand up. For the champions, stand up. Stand up. Stand up. Stand up. Here we go. It's getting close. Now it's just who wants it most.